These are going to be some advantages and limitations of it. Basically, to sum this up, the robots, so that computer modeling software develops the MOS, whereas the humans, us, create the TAF. Which is better? You decide that personally. A cool thing that you could do with yourself to basically note the differences between a TAF and MOS would be check your local airports for both of them, maybe for this evening, right? Note some key differences between them, like is it going to rain or not? Is it going to snow or not? Depending on where you are in the United States. Set an alarm on your phone for that scheduled time and then observe the weather. You will see what's actually happening during doing that, and then read the METAR. So those can be some ways that you can note the differences. At ATP, we don't really use the MOS, but just know that it is there. I'm going to go ahead and drop a link in the chat, but first let me make sure that it works. Okay, perfect. So this link is just basically a virtual lab. It's going to be the first one for on Google. Once you input it in, you can play around with that if you would like. But now we're going to switch gears. We're going to go talk about winds aloft. So of course, winds aloft, this is going to provide these winds from 3,000 feet to 53,000 feet. And that's going to be out of 6, 12, and 24 hours. This data is going to be extracted from the MOS, so that model output for individual airports represented by that 3-letter identifier. Then that data is then going to be grouped by region. It's not going to be reported within 1,500 feet of the station though. And then again, DD just means wind direction, FF means wind speed, and TT means temperature in Celsius. So breaking these apart. If those winds are less than 5 knots, it'll be coded as 990, meaning that those winds are just Latin variable. Now let's say it's greater than 100 knots. If it is greater than 100 knots, that just means that you're going to have to subtract 100 from that wind speed and then get that number from there. So you're going to have to break apart these altitude by altitude, what the wind speed is, what the temperature is, and what the direction of that wind is. So again, this is what I'm talking about. I'm sure we've all seen this. We've all done a nav log. You should be very knowledgeable with winds aloft. And again, you can also get them from Aviation Weather Center. That is what these are going to look like on Aviation Weather Center as opposed to this on ForeFlight. Again, this is only providing you winds from 3,000 to 53,000 feet out of those 6, 12, and 24 intervals. And they will not be reported within 1,500 feet of that station. Again, 9900 just means that that wind speed is light and variable, and so is that direction. It does give you that temperature, which is just 12 degrees Celsius. Here we see that we are okay, so that wind direction is 250 degrees at 12 knots, and that temperature is 2 degrees Celsius. Here we have to do a little bit of math. So that's where we minus 50 from whatever the wind direction is and add 100 to whatever the wind speed is here. Now, there is a different way of doing this, which is going to entail another YouTube video, but this is ATP's way of wanting you guys to learn it. Of course, you probably already know this, but I just have to do this because ATP wants me to. So this is another video that we're going to watch. He does explain it a little bit differently. Again, if you already know this, that is okay, but he does it a different way. It is more simple, but it is up to you.
Everyone, Jason Schapper here of M0A.com. And today we're talking about aviation weather, actually talking about winds aloft reports, how to read them and really how to apply them when you start doing your cross-country flights, as I'm pretty sure it'll probably even come up on your check ride. So the website we're on is aviationweather.gov. You can see that there.
Can everybody see the screen? Yeah?
Here.
Okay.
Where I want you to go is winds and temps. Over to wind/temps text. You'll load up with this nice little kind of interactive map here showing all the different stations. And we're going to go to the West Coast for some of our examples today. So we click on that, and one of the first things I like to do, let me first zoom in so you can see it better, is read all of the notes on our winds and temps aloft. So this is an FD, is what it's known as, kind of like a METAR or a TAP. Well, this is an FD. This we'll just call our winds aloft, winds and temps aloft report. You can see it's valid for use from 1400 Zulu to 2100 Zulu, and this is on the 26th. Another important note to read is the temps are negative above 24,000, and of course this is going to be in Celsius, and temps negative above 24,000 is pretty standard. So what we want to do is, first things first, for those of you that are taking notes on this, I want you to write down a few things. The first is that all altitudes through 12,000, this is how we're reading it here, these are our altitudes here, all the way across. These altitudes through 10,000 are MSL, mean sea level, okay? Above that, 18,000 and above, these are now pressure altitudes. Some other things you're going to note here, we have some blank spots. Well, no winds are forecast within 1,500 feet of station elevation. Also, no temperatures are forecast within 2,500 feet of station elevation. So let's go ahead and read through a few of these here. For example, at 3,000 feet at the Bravo Lima Hotel Airport, the winds are, first two numbers are our direction. Okay, second two numbers are going to be our speed. Winds are 280, this side here, at 6. At the Fat Airport, Foxtrot Alpha Tango, the winds are 320 at 12 at the end there. If you run into a 9900, winds are light and variable. Now here comes in a little temperature stuff here. Winds at 6,000 feet at the Bravo Lima Hotel Airport, 250, first two numbers, at 21, temperature plus, so a positive, 18 degrees Celsius. See how we did that? Winds light and variable, 6 degrees Celsius on the positive side. Winds 240 at 17 and plus 1 degrees Celsius. Okay, let's move into some more complex things. Obviously over here you can see this is just showing us it's a negative temperature. They'll show you positive, negative, but remember, all temps above 24,000 are assumed negative. So let's look at some more complex ones here. Here, at 30,000 feet. Just looks like a bunch of numbers, right? Okay, so our winds are 280 at 78 knots, and our temperature is minus 36 degrees Celsius. Okay, so we got that one. Hey, what about this one here? What on earth is that? 78, 17, 37. How on earth am I going to interpret that? Well, again, if you're taking notes, if the direction is more than 360, so obviously this is going to be way more than 360, what that's telling you is the winds are greater than 100 knots. Again, they can only fit so many numbers in, so this is how they're telling you the winds are greater than 100 knots. So what you want to do is you want to subtract 5 from this first number, which gives us a 2. So that tells us the winds are from 280, and we know the winds are 100 knots or greater. So what you want to do is you want to add 100 to this wind speed to get 117. And the temperature is minus 37 degrees over here. So 280 at 117 knots, temperature's minus 37. Let's try another one. Let's try the next altitude, 34,000 feet. Okay, so we're looking at this one now. Again, you subtract 5 from this very first number here to get a 2. So these first two numbers, that it would be a 2 and an 8, be 280 at, well, we add 100 to that wind speed to get 118. And our temp is minus 47 degrees Celsius. Now, another thing, if you saw, and I don't know if there's one on here or not, I have to look through it a little bit. If you saw like a 7799, somewhere in here, 7799, something like that, would show you that the winds are greater than 200 knots. And they're not going to give you the exact velocity of them. They're just going to say, hey, those winds are kicking. They're over 200 knots. And I don't know. They pop up every now and then. I don't see one here. But that's to know that they're over or greater than 200 knots. So the main things to remember with winds aloft, remember, through 12,000 is MSL. Above that is a pressure altitude. No winds are forecast within 1,500 feet of station elevation. No temps within 2,500 feet of station elevation. And remember, you want to subtract 5 from that first number if you think you're going to come up with a really weird number like 780. It's not possible. So if it's greater than 360, consider subtracting 5 from that first number to correct it there for you. That's all I have for you guys. Hopefully you're...
Okay, so basically, instead of 50, he used 5 from 7. Not 5 from 73, but 5 from the first number, 7. So that was his way of doing it. If it's easier for you, by all means, use that one. But again, this is ATP's way. But yeah, with that being said, we're going to jump into airmets. The 3 different types, we should know this. Sierra. So Sierra is going to be our mountain obscurations and IFR conditions, right? Tango, that's going to stand for turbulence, or if we have surface winds greater than 30 knots. And then Zulu, of course, is going to be icing. So this is going to be moderate icing and freezing levels. Again, the valid time for that is 6 hours at a time. And I think we all know this, right? By a shake of head. Yeah. Okay. Perfect. Segment. How long are these valid for? 4 hours. Good, good, good. What are some things that segments are going to be issued for? Everything above but higher. Volcanic ash. Okay, good. Good, good, good. Yeah, we're going to have everything but higher in our segments. They are unscheduled, but they do last for, I think they're issued, yeah, they are issued 4 hours, but for hurricanes, they're going to be 6 hours. Here in Florida, we see them a lot during that hurricane season, and they are valid for 6 hours. Again, some things that is going to be issued for is those non-convective weather conditions, such as your dust storms, severe icing, severe extreme turbulence, that volcanic ash, and sandstorms where that visibility is going to be less than 3 statute miles. Again, not related to thunderstorms. We all know this. This was just a review. Just note that if you do get asked on a check rod, well, when does the validity of this change? It's going to change if there is a hurricane. Would you cancel your flight if you saw a segment along your route? Why or why not? Drop it in the chat, or feel free to come off mute and chat with us. Depends, yes. What does it depend on? Why do you say it depends? What it was issued for, okay? I have 2 yeses, 1 says it depends. Does anybody else have an opinion? What it? Okay, yeah. Well, of course you want to ask that follow-up question, what was it issued for? That was a good question to ask. Also, are you fine VMC, IMC? For simple terms, me personally, I would just avoid it. I would want to think twice about it. They can be dangerous, right? But some of them may require that careful planning and or just most likely that cancellation of that flight, that no-go decision. But again, you guys are abiding by your own personal minimums. You know what you can handle. If you did that thorough pre-flight, you could see if it's actually along your route or on the outskirts of it, right? So those are just some things. Now, convective segment, how long are these valid for? 2 hours. Good. Right, so some specific things. We have those line of thunderstorms. So those are going to be at least 60 miles long with thunderstorms affecting 40% of its length. And then we also have area thunderstorms. This is going to be covering that at least 40% of that affected area. And that's going to be exhibiting a very strong radar reflectivity, as you can see on the screen, right? Or significant satellite or lightning structure. And then also we have those embedded thunderstorms. These can be expected to occur more than 30 minutes. So those are some things we need to note. And then when it says special issuance, this will be, I think it's discussed on the next slide, but for convective segment, if there is a special issuance, that's going to regard whether there is hail greater than or equal to 3/4 of an inch in diameter. We have tornadoes, or those wind gusts are greater than or equal to those 50 knots. So again, this is exactly what I just explained. We know that any convective segment is going to imply that severe or greater turbulence, right? And severe icing and low level wind shear. A convective segment may be issued for any convective situation, whichever the forecaster feels is hazardous to all categories of aircraft. When it's talking about bulletins, which you'll get into the more you get into weather, bulletins are going to be issued hourly at an hour plus 55 minutes. So the text of that bulletin is going to basically consist of either an observation and a forecast, or just a forecast. And if it is a forecast, then it's going to be valid for up to that 2 hours. Again, if you do overlay this on ForeFlight, it's pretty easy for you to notice if it is an airmet segment or a convective segment. It's going to be color coded, and if you click on it, it's going to give you that information. So regarding PIREPs, what is a PIREP, right? A PIREP is just that pilot report in regards to actual weather that a pilot is encountering while they're airborne. Typically, pilots file a report to ATC or your FSS, right? When these weather conditions are not the same as forecasted. Or when those conditions are actually worse than the forecast. That low visibility, turbulence, icing, and thunderstorms are going to be good examples of actual weather conditions that may not be in the forecast, but may be conditions a pilot experiences during their flight. What a pilot doesn't realize, right, is that a PIREP should be filed when that weather is even better than forecasted. A PIREP filed to report good weather is just going to be as important as a PIREP reported for filing that bad weather. Let's say we didn't go up today just because there was maybe convective activity around, or winds were greater than our personal minimums, but actually once we got up there, it was completely fine. That's where filing those good PIREPs are going to come in handy for us. One more important thing I want y'all to keep in mind is if you do file a PIREP, right, they should be as complete and concise as possible. We shouldn't get overly concerned with the strict format or phraseology. It's an important thing to relay that information so that other pilots can benefit from your observation. Not all ATC workers are pilots, so sometimes they have no idea what you are even saying. And again, ATC is going to require PIREP when ceilings are below 5,000 feet or that visibility is less than 5 statute miles. What do we think? Yes or no? Drop it in the chat. Are PIREPS reports regulated by or required by regulation? What do we think? Good. No, it's not. It is optional. However, it is our duty to file PIREPs even if there isn't a specific regulatory requirement for us to do so. This is going to be reported in 91-183 Bravo, just stating that that pilot in command of each aircraft operated under these IFR controlled airspace must report any unforecasted weather encounters as soon as possible. And again, that reg is 91-183 Bravo. But the answer to this is no. But there is a however part. Again, this is what PIREPs do look like. There is, let me see if this even works. Give me 1 second. Okay, lovely. It does not work. But there is free PIREP training in the event that maybe you are uncomfortable with that right now. You can practice online. It's for free. It's called PIREPs Made Easy, and it should be by Air Safety Institute. But yeah, that is free. If you don't feel comfortable filing one or have never filed one, you can practice with that. Also, these are 3 different disseminations of PIREPs and how they look. They kind of do look a little older, but again, you can see how short and concise this is. It's nothing like a METAR or a TAF. Has anybody filed a PIREP yet? No? Okay. Questions. When a METAR reports OVC 010, what does it decode? Yeah, C is the answer. We always add 2 zeros to the end. Good, good. How long are TAFs valid for? Yep, we should all know this. The answer is B. Those are the typical modalities of the TAFs. That's why we need to make sure we examine those charts for what's written on there, just in case it was 30 hours. Which of the following air mets are reported for icing? Good, good, good. Zulu is the answer, A. And last one, which of the following are real-time weather reports given to FSS? Beautiful. The answer is A, PIREPs. Any questions, comments, or concerns? No? Yes, maybe? Okay. Come back in 15 and then we'll finish up class.